do have a big team actually from all over the world to participate the activity. We usually do every 2 months we have meetings, depending on how to say which day we have the different time lot to cover each time zone. So we have, I couldn't remember how many meetings we had, but I usually have 2 months. But it's my fault that maybe we missed one or two in the middle. We do have 3 tasks. Actually, we finished 2 tasks in the last 2 years. The first one is inter-comparison of level 4 SST products. We had a paper in Journal for Climate. We have another task is to understand the differences among all the level 4 data products. Also was completed last 2 years ago. The one paper published also, I think, is a Journal of Climate as well. So the what we have been working on in the last years, task 3, which is to compare features in different level 4 products. We have 6 subtasks and 1 potential future task. So in the following presentation, I'm going to present to you what we have accomplished and how to say what we're going to do in the next. The first one, task 3.1, is to validate level 2, level 3, and level 4 SSD gradients using Cedron data and a SHIP SSD. It was led by Jorge. Actually, the one paper is already published. In this task, they have used 8 Cedron deployments of the US West Coast to validate MODIS level 2 and Muir level 4 SSD. Actually, they have found, you see the on the left, they have the study areas, the west coast of the US, and this is the Cedron data and the trajectory of the Cedron. What they have found is that they have very bad accuracies for the Muir products, but they also the main outcomes, they demonstrated the ability of Cedron data to accurately validate nearshore and satellite SSD products. Sorry, I have maybe it's missing one word. On the this is the first task is finished. We have the task 3.2 is to produce online visualization tool for the level 4 SSD fronts. Actually, this one is the snapshot of the website. It's still in progress. It's fresh. It's in the room. The snapshot I have presented here is the SST, actually the ocean fronts based on the SST products. But you definitely, if you go to the website, you can also have how to see the salinity, sea surface height, ocean color, and also storm tracks. It's really nice websites. Like I think during the question how to say answer sections last, one person asked the ocean color. That's the how to say the last potential task we would like to handle in the following years. The task 3.3 actually is to develop the science to calculate SSD fronts and to intercompare. It's led by Daniel. Daniel Chan is also in the room. It's based on the ESA project. It's ESA Earth Explorer, particularly the Harmony missions. The Harmony mission aims to contribute to the ERC interaction studies by co-located measurements of sea surface roughness and SST gradients. They proposed to actually to retrieve SST gradients from the panchromatic channel because it has higher resolution than other channels, and there's no inter-channel co-registration. Our approach is to test the existing dataset as Sentinel-3 and to have the optimization of the gradient estimates. This approach actually, this study has been presented in the last, during the GREAST seminar. You can, here's the link. You can also go and check the presentation. This is also the result. Sorry, this is a second. On the left side, you see the SSD gradient intensity with the Sobel way of calculation. On the second, on the right side, you see the Sobel gradient from the Sentinel-3. Actually, the gradients locations are very close for based on these two, how to say, images. Definitely, if you have any questions, please ask Daniel, who's in the room. On the right side is the optimal optimization of gradients estimates from a radiometric noise. The conclusion of this study is that the PAVE11 after performs the other gradient schemes in the presence of noise, actually, because it has the best agreement with analytic cases. So if you are interested, we also have a paper on this study. Task 3.4 is about validated SSD gradients in all fronts with other independent data, but not related data, for example, X-stress and Seldron. It was led by David, Nico, and Jorge. On the basically to see this figure, to see the noise levels between X-stress and the Seldron data, on the California upwelling fronts. You see that on the right side, actually the figure in the middle is the black line is bias corrected X-stress data, and on the red line is the seabird and how to say the 5-minute samples, and heat track infrared is the blue circles. The conclusion, sorry, the conclusion of this study is to see how to say the there's a robust standard deviation of the data and the data. Go to the Gaussian standard deviation, but then I go to the next. On the left is the skin data on the skin temperature from echo stress, and also on the right is modest chlorophyll. Again, here's the ocean color data set. The conclusions that the bias corrected echo stress SSD is very highly correlated with Sidra SSD. But the modest level 2 chlorophyll and SSD have underestimated the variability because 1 kilometer resolution is still too large. How to say, also X-stress in the future, Therese Shana, I think maybe colleagues for this information in the room will be able to provide 2D context to trajectory data from autonomous how to say sensor platform like Sidra actually in this case. Definitely, if you have questions, I think David is online. You can have a write in the chat. Here, for example, is the echo stress Seldron trajectory on the. I will go direct to the second one because this is the how to say the filament based on Sidra and X-stress. You see the blue line X-ray is X-stress data, the orange line is the Sidron data. It's basically the both of them, they can capture the upwelling filament, and they can see also the drop of SSD on the left side. You see on the trajectory, and you can see also both the data set can capture the signals. The other task, the half of the task actually is led also by Jorge, to use salinity data actually to validate SSD gradient. It's the it's like independent data sets. The study area is still on the western coast of the U.S. on upwelling California currents. Actually, both SSD and salinity, they can capture the coast upwelling. The differences between, definitely they have a little bit difference. The differences between SSD and salinity gradients mainly associated with the limitation of the salinity and how to say derive the microwave derived SSD coverage. The salinity coverage. This one's also finished. Jorge already have a paper published. The task 3.5 is still in progress. It's part of the ESA World Circulation Project project is to compare feature resolution and spatial consistency of various level 4 products. The project of SWOC, water circulation project, okay, to generate 2-dimensional and 3-dimensional marine currents products. Actually, they have used North Atlantic as one and test areas. Yeah, that's the currently still in progress. Still, Daniel's in the room. If you have questions, please go to him to discuss. This is the they have used the Peterberg 2009 methodology to retrieve the currents. Definitely, as SSD gradients also used as like not an independent independent data to correct the factors due to the altimetry geophysical geostrophic currents. This is the methodology they have used, and definitely the method. You can also check the papers for the references. They have used the reprocessed OSDI SSD and both near real-time and reprocessed SSD dataset to test the methodology. Definitely, the altimetry data from the DOCA is actually the the Aviso dataset. Okay. And then, sorry, it's a little bit slow. Here's the result. Actually, they have used drifting buoys to validate the derived currents. On the right side, you see on the top is compared to the OSDI near real time. On the bottom, sorry, it's not improvement. Yes, improvement compared to the OSDI reprocessed. The blue ones means not improvement, the opposite. The red squares means the improvement. You see, based on the right side, meridional currents. To me, definitely, then you can add in the comments. On the right side, the meridional seems like meridional currents have more improvement compared to the zonal currents. Okay. Definitely also, he pointed out that with the reprocessed OSDI, the performance is much more enhanced compared to the near real time. The other one actually also in progress. We are a little bit slow, but I think by the end of by the end of this year, hopefully next GRIST meetings, we could present our result. Is task 3.6 to compare SSD gradients over seasonal and into time scales for various high level 4 products. It's led by Danny and myself. On the bottom is the SSD gradient in Muir 0.25 degree, and on the right side is SSCCI, but we interpolated in 1/4 degree. This is still the older result. We haven't updated it yet. We hopefully in the following month we will progress on this task. Task 3.7, just like what I have mentioned during our task team meetings, we all believe that by using ocean color we can compare with SSD fronts. I think it's like independent inter-comparison could be very interesting to see, like what one person asked the accuracy of ocean color and SSD dataset. It's a potential new task. I think we will in the following month we will see how to proceed. Definitely, if someone's interested in this task, please let us know. We can how to practically start the task. Yeah, that's what I have. Thank you so much. If definitely, Jorge, if you have anything to add, please.
No, thank you. I don't have any any further comments at this point. That was great. Thank you.
Should we have a look if we got questions from the audience?
Maybe I stop sharing, so otherwise I don't see.
Yeah. So there is a question online from Christopher Merchant.
Hi, thank you for the presentation. it's very nice to see these validations of gradients and so on using Saildrone. I think this is very interesting, and look forward to reading more about it. Just a comment and question. It's not only the resolution of SST sensors that can affect the gradient. I mean, we have at least theoretical predictions that different types of algorithms are differently sensitive to gradients. I wondered if it's in the plan to think about looking at maybe the same example, but with a couple of different types of SST retrieval, you know, NLSST, maybe a 3-channel retrieval, different types of retrieval, to see whether the differences we expect to see in the retrieved gradients look like we expect.
Jorge, you would like to add, or?
No, I mean, Chris, I think that would be fantastic. And one of the things that I was working with a doctoral student who did that paper that Chunxue mentioned, and she compared the Saildrone with level 2 Modus and also the mirror product, and that kind of goes back to that question that was asked about, you know, using level 3. But one of the interesting thing was that, you know, she found a lot of differences, and obviously in the comparisons with Saildrone, depending on the quality flag that she applied and all of that. So, I mean, the issues, I mean, that's where I think more work needs to be done. I'm sure there were issues with respect to cloud masking and all of that, but that's where I think, yeah, I mean, if this somehow we, you know, be able to compare different algorithms, I think that would be fantastic. Absolutely. Yeah, because she found some very interesting results where there were just huge differences between applying a quality flag of 0 to 3 or 3 to 5 in the level 2. She found a lot, you know, just very, very large differences.
Yeah, thanks.
There is a question from Andy.
Yes, please.
I guess it's probably in the paper that I haven't read, but Danny's paper, but that was quite a striking improvement using the reprocessed ostia. So why? What works so much better for that? Have we got any idea?
I think that Daniel.
No. So I don't know if Danny can talk. Sorry, I jump in because
He's
oh, Danny, do you want to?
He's coming in.
Yeah, okay.
Hello, everybody. Yes, thanks a lot, Andy, for the question. This is something I'm sure Chongyang will jump in at some point. Something that we have been discussing exactly last week with Chongyang. We are trying to figure out why we have this striking difference in the retrieve current improvement when we switch from near real time to a reprocessed dataset. My impression, my understanding of the problem is that in the reprocessed dataset, gradients are more accurately described. I performed a very quick snapshot analysis on some test cases, and of course, for very severe cloud conditions, let's say, you have strong differences between the near real time and reprocessed gradients. But also in cloud-free conditions, we saw some differences, mainly along the major mesoscale features along western boundary currents that are very likely generating these different results in the reconstructed currents. But I'm sure Chongyang can add some more details on the reprocessing of the on the algorithms that are behind the generation of these two data sets. Thank you.
Yeah, so to answer Andy's question, yeah, so basically that for the time period Danny looked at, the near real-time version is still using OI for DA, and the reprocessed version is using NemoVal already.
Yeah.
And also for the NemoVal, when we implemented it, we added a special flow dependent element to it. So that's why around the fronts you would see big improvement. So I think what Danny's results show makes absolute sense to, in particular for the front bit. And also, there are some detailed difference between the near real time and the reprocessed ostia, but that's, I think the change of DA method and the flow dependent element would probably show, well, that's what in fact then impact Daniel's results most. The other, in terms of detailed observation types, are not identical. I don't think that will bring in that much of impact. But I can let you know afterwards.
So with the flow dependence, where does the flow come from?
There is a paper I can send you, because I think it got details in there, and then that was like 5 years ago, so I can't remember exactly. I think it's something to do with the background covariance, how that's been applied.
Okay.
There are some scales, like what's the length scales, I think, was different in the two versions of near real time.
Right. Okay, but it's not
yes.
doesn't use any external data to derive flow, near real time flow then.
No, I don't think so.
Okay.
I
Like
think
altimeter data, for example. I mean, it's right there.
Oh no.
I'm just
I
saying,
don't think that's
it's right there.
It is no. I don't think it's from that, but I think it's from a memory. I think it's based on the background covariance, something like that.
Fair enough.
Thanks. Yeah. Thank you.
Okay. Yep. Yes, sure. Any more follow-up questions on this from online? If not, then Ed has a question.
Okay, I have one comment and one question to the IC tag folks. My comment is: are you thinking about looking about intercomparisons between gradients from SST and SWAT? You mentioned ocean color. I would think it'd be the first thing I would want to jump at is SWAT, high resolution, once it becomes available. That's responding to the physics. Okay, thumbs up. Thank you. So yeah, I would definitely recommend adding that to your emerging responsibilities or goals. My question was, you might not be able to answer this, but I'm curious if you can give me some idea of what is the wall clock time, right? What is the compute wall clock time for doing a comparison between two data sets, comparing the gradients, so you have to get the data sets and you have to regrid them to some common resolution, then perform the gradient analysis and then do the comparison. So can you give me some idea of what those typical wall clock times are? Are we talking about days or hours? Because you guys have done this experiment now.
Yeah, it's for the SWOT is a good point. Okay, we already we never discussed during the task team, but we can start the discussion to see how to do so. In terms of the wall time to calculate the SSD gradient, particularly you just mentioned, it's a pain. I couldn't remember how much time we have to do so. Maybe Daniel, you have some ideas, but it takes very long. That's why we didn't, how to say that. We were thinking last year to start very quickly to have the results, just because of the calculation time. Particularly, we have, like what you mentioned, we don't have to download the data because we have, but to do the interpolation, and particularly with the daily data to do the gradient, it takes a really long time to do so. It's I would say not a few hours, it's a few days to depending how many days we're going to include. It's a lot of work. I agree with you. But also, so that's why actually we have to do it in any case. We need to see with Daniel, we have discussed, maybe we are not going to do, how to say, really like a global. We can select a regional, few regions. In this case, maybe we can be efficient. So that's the, how to say, idea. Yeah, you pointed out a very critical problem. Yeah.
Yeah, I understand. Certainly, it depends on the region and the space scale you do the operation on. But those maps you showed were global. So yeah, I would say that's kind of the answer I expected, guys. And have a look at like cloud computing. I'll have some discussion about that in my presentation on Wednesday. I think there's something that can be done to speed up operations such as what you're performing. So thank you for that. And just I'm done.
Sure, thank you.
All right, we got 3 more minutes for this particular presentation. Any more questions here? Helen, it's a quick one. We got 3 more minutes. But you don't need to run. It's okay.
Yeah, I know I've been saying this at the last few GRIS meetings, but I mean, sail drones are fantastic because you can tell them where to go and they can measure frequent SST observations and other types of data in coastal regions that are in eddy fields, whatever. But there are other high resolution, accurate in situ SST data that you can use from ships of opportunity, and they don't cost much at all. They're really cheap, much cheaper than sail drones, as provided that they go in repeat transects in near coastal regions, like passenger ferries that go back and forth near to the coast. Now, what you need is probably 1 minute or SST data every 1 minute or maybe every 10 seconds or something like that. Well, we have some of that data. We have years of that data. It is not being used. Sometimes it is, but it's just there. It's available and it can be used to measure SST gradients near the coast. That's all. And there are other ships around the world too that are doing this. So just think about ships of opportunity. Sail drones are not everywhere. They are very expensive and we only have a small data set. Thank you.
Yeah,
Thank you.
Excellent point.
It's a good point. I think we can discuss how to explore these data sets. Sure. Yeah. So sorry.
Yeah, good point. Especially many countries actually have the ships of opportunity, including India, Indo-X experiment, all this stuff. Right? Kind of aware of those.